Okay, hello. In this lecture we will be dealing about orbitals. In the last lecture I gave you an introduction to orbitals. Okay, now I'll give you a more introduction, a more specific introduction. Okay, let's consider an atom of hydrogen. Okay, let this be the nucleus. Let this be the nucleus. Okay, the nucleus. Okay, now what I'm gonna draw is that we take multiple pictures of the atom of hydrogen, multiple pictures, and merge them together. So we'll get a lot of electrons because all of these figures have electrons located at different places, right? You said it's a probability function. Okay, I'll be drawing the combined image. Or I think I'll do it in this one's going to be better. Yes, quite better. That was very thoughtful of me. This is a a collage of a lot of images, because you need the number of images should be as much as the number of dots over here, because hydrogen has only one atom, right? Okay, now as you can see, over here it is more dense, and you can even see hydrogen over here, or even over here, the electron, but it is dense over here. So what we can say that the probability of finding an hydrogen atom is more over here, for this region, right? Because it's more dense over here. Like we saw in the last figure, the last lecture, we saw the atom of a hydrogen, right? Yeah, whatever. My lectures don't have any kind of relation with the previous lectures. I'm doing in such a way so that anyone can understand any lectures. Okay, now I have the periodic table over here. And as you know, we have different groups in a periodic table. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, 18. I'm lazy to write the rest. Okay, we have 7 periods also. 1, 2, 3, 4, 5, 6, 7. 7 periods. This actually comes over these group, the actinides and lactonides come over here, which I'll talk about later in the future videos. Okay, what is the first of all, I'll give you an introduction to the shells. We have 4 shells, 4 orbitals, sorry, S, P, D, F. These are the 4 orbitals. Now the number of electrons an S orbital can accommodate is 2, whereas a P it is 6, and a D it is 10, F it is 14. Okay, now we'll first do the electronic configuration of hydrogen. I'll first do some electronic configurations which you will understand from that how we configure later. Hydrogen, the electronic configuration of hydrogen. When we write it, first we write the name of the period or the number of the period. Hydrogen is in the first period, right? First period over here, 1. Then we know that first the S orbital is filled, so 1 S. And the number of electrons, what is the number of electrons? It's 1, right? So we write 1 over here. The electronic configuration of hydrogen is 1s1, and I'll write helium. Helium is also 1s, but we have 2 electrons, that's different, and we know that S can accommodate 2 electrons, so 1s2, right? 1s2, that is the electronic configuration of helium. Now lithium is 1s2, and it's also we also have 1s2, and a new period is there, 2. So we have 2s1 also. And it comes to beryllium, we also have 1s2, 2s2, right? Okay, now one thing you need to know before I configure boron is that these two groups over here and helium actually, when we do it in orbitals, it actually comes over here, because that gives a more, it has only s, right? Okay, so this is the two groups where the s orbital comes. Okay, these two groups will have s, their outermost, or I think, okay, these two will have s. So then these two, I mean these 5, 6, 7, 8, 9, 10 groups will have the p orbital, and this will have the d, the transition metals, and this will have f. Okay, now lithium, we'll do lithium, sorry, not lithium, we'll do boron. Boron comes under p. So how does its electronic configuration come? Like the last two ones, 1s2 is filled, then 2s2 is filled, then we have one more electron where to accommodate. It's not in the third period, so we need to have one more in the 2, so we write it as 2p1. okay, 2p1. Now this will have the outermost 2p2, 2p2, 2p3, 2p4, 2p5, 2p6, and again we go to 3s1, 3s2, like that we go on. Okay, I'll do with the D and F in later videos, since it's quite confusing even now. I think we have 5 minutes more, and I think you don't have quite an idea of what I just taught you. I mean, D things, when it comes to the DSPDF, you don't have quite an idea. I'll give you an idea, but it's not actually true, which will help you understand better. Okay, I'll draw some structures. Let this be we'll consider some atom, some big heavy element, so that we need to show all these, right? We need to show SPDF, some heavy element. Okay, let this be the nucleus. The nucleus of the atom. It's a nucleus. Now the first orbital which comes, as we know, it's 1s, right? So let 1s be this. So the probability of finding an atom which has hydrogen will be in this. Doesn't mean that it will only be there. It can go over here, it can go over here, but it will be dense over here when we take multiple images. Now the next one is 2s, right? 2s. You don't have 1p. 2s will be a bigger round, a bigger one. So 2s will be something like this. Now 2p. The structure of p is different. Like that. Structure of p comes like this, something like this. This is the structure of p, something like this. Okay, now you have to understand something. P has 3 dimensions: the x, the y, and an z. It'll be like this. Okay, just consider it in 3 dimension. Now after the 2p comes 3s, right? 3s. After 2p comes 3s. 3s will be a bigger round, and what will 3p be? 3p be a bigger structure of this, a bigger structure. So actually it doesn't include this part, right? It doesn't include this part. So we will consider this. Oops, sorry, wrong tool. This part actually comes as the 3p. This part and this part is 3p. Okay, for that, for every dimension, I'm not drawing the ones for the other direction, I mean other dimension. It will be quite crowded. So why do we have a D? We can just continue on like this, right? Why do we need a D? Now that has a possible explanation. We have space over here, right? We don't need to consider this one, this P over here. We need because we will consider this one dimension. So we have free space over this area. So that is why we need D. We need D to fill this area. This area. D is actually something what like this. Fan. Okay, and we understand that you cannot see D. I'll show that D is something like this. Somewhat like this. Okay, that's D. So it still comes under 3. So even if the D is in the fifth period, the D is in the fifth period, we write it just as 3D. Sorry, we write it as 4D if it comes in the fifth one. 4D. If it comes in the fourth period, we write it as 3D. Whereas it comes in the fifth one, we write it as 4D. I will tell you about later in future videos. No, that's all. It's something, you just leave this. You don't need that part. I'll talk about that later. I just simply draw the structure to show you, somewhat to give you an idea how the electrons are arranged and why do we need a classification like this. So thank you.